Okay, in this session, we're going to create a sheet metal pan with a couple of knockouts. Let's say we've got an LCD or some buttons that we're going to install on this. Plus, we're going to put in some PEM nuts, press-in PEM nuts. We are going to close up these gaps so that they're easy to weld and create a flat pattern out of it. But this is essentially what we're going to be looking at. We're going to go one step further by creating an assembly and actually grabbing some PEM nuts from McMaster-Carr and inserting them or constraining them to the holes that we've created. So let's go ahead and start out with File. Go up to File, go to New, go to BVAN, Sheet Metal, which we can change that on your guys' template file so that it doesn't say my name every time. Anyway, we're going to go back into that. We're going to go into the f of x, the parameters. We're going to scroll down. The first thing I want you to do, majority of the time, if you're going to be flattening a part out, you want to right-click, not left-click, right-click on that variable and delete that parameter. Right-click on that variable and delete that parameter. The reason why we do that is when we do the flat pattern, we want the length and the width to be the actual flat that's being cut out to be length and width. So let's go ahead and add a few user parameters, and I'm going to go with formed width. And don't feel like you have to always do the parameters, the user parameters. It's just a habit that I've been in for a long time because I drive a lot of my models from an external database. A lot of them are much larger where I don't want to have to keep track of a ton of different formulas. So it's kind of a habit, I guess, I've had over many years. Even on the simplest parts, it's easier just to come into the parameters and change this instead of having to come over to your browser and try to find that specific feature. Anyway, let's continue. So the form width, let's make it 12. Add numeric, let's do formed length. Let's make that 28. Let's go return flange. And again, this is all preference, user preference. You do not have to put the underscore in there. You cannot have a space, but you don't have to put the underscore. You could make it all one word instead of having the underscore. Again, it's just a habit that I've had for a long time. PEM underscore nut hole diameter. So what I did do for this PEM nut hole diameter is I went over to McMaster-Carr. I found a standard 1/4 20-inch thread for a panel that is thicker than what we're going to make, which we're going to be using 14 gauge, which is just slightly over a 1/16 of an inch, 0.0747. And it tells me diameter of mounting hole required is 0.344. So that's what I'm going to use in here, and that's what you've seen. So there it is. PEM nut hole diameter is 0.344. Now I could go in there and put PEM nut, H-lock, V-lock for the locations of the holes, but we're just going to go ahead and drive those with a standard dimension. Just to show you that we do not need to have a user variable. And here I'm going to start my knockouts. I'm going to say my knockout length 1 is 8 inch. Knockout width 1 is, what was it? It was 6. Knockout length 2, and I should have just copied it out, but that's alright. We're here now. Let's make this one 10 inches. Knockout width 2. We're going to make that one, pardon me, 3 inches. So that'll give us most of our variables to start the sheet metal part. Click Done. And the first thing that we're going to do is we're going to create this face. Just this face, not the flanges. So let's go back over to here. It's already in Sketch. You can see here. I'm going to click on Rectangle. Come to the origin point, 0, 0, 0. And you can put in formed length. And then you can put in formed width. or you could click on your little arrow and find it in the parameters. But I tabbed through it, and now it's good to go. So you see these little f of x's in the dimension itself. That means it's being driven. That little f of x there matches this little f of x. If I double click on it, it's going to tell me that it's dimension D1394, or it's referencing the formed length. Alright, so now we've got the face of the panel. We're going to come over to the sheet metal tab, go to sheet metal defaults, down click the arrow on the sheet metal rule, and we're going to go to 14 gauge. Let's do galvanized. And we're going to apply that. Say cancel, and we're going to go to underneath the sheet metal tab again. We're going to go click on face, and I'm going to hit F4. It's function F4 for you, but you can see that the thickness is coming off this way. If you wanted to, you could send it back the other way or do it midpoint, but for the face of this, we really don't care. I'm actually going to send it back, and we're going to go apply, and there is our face. Okay, so let's start putting some flanges on here. So underneath of the sheet metal again, you're going to click on flange. We're going to go ahead and assign that variable for the length of the flange and find return flange. And we are going to just go ahead and select the edges. And it's very picky about which side. You want to pick on all the same sides. If you're going to be creating a pan like this, we're going to pick on the same edge for each one. And we're picking on the edge that is on the face that's closest to us. If I zoom back up, which that's kind of a confusing view there, you can see this little cyan or the light baby blue line. We're picking on the edge that's closest to us, not this far edge. But the thing is I want to flip this around. So we're going to come back over here, and it says flip direction. Perfect. I want to flip it that direction. Now you can kind of see in here, this is a pretty decent sized gap. Welding that shut would be kind of a pain. So I'm going to go into corner, and I am going to change this miter gap. The gap size, I want it to be probably something like this. This is what we typically used up at C&T. You don't have to. You could give yourself a little bit more grace there, but I would suggest leaving it about like that if you're going to laser cut it. If you're going to plasma cut it, I would probably do more of a 30-second or so. But we're going to leave it nice and tight for now. Some of the other options that you can do, typically we always use tear. A lot of people will use a round. A lot of fab shops will use round. It just helps when you're forming these parts up that you don't get a little pucker factor in the sheet metal in the corner, this top corner. But if you use the right size tooling, you won't have that problem. So again, we're just looking at the corner here and changing that miter gap in the corner to 0.01. We'll go ahead and apply. And again, one of the things that I've done for the longest time is always cabinet corners for the welds. Gives you a nice finished look. And we'll go back to the front view. Now we have ourselves a pan. So let's go ahead and place the knockouts next. So I'm going to click S for sketch, click on that face, come back up to underneath of the sketch, rectangle, and I'm going to draw two generic rectangles. First thing I'm going to do is go to make sure that my view is the front word is horizontal. I'm going to click on vertical. I'm going to pick on the center point of that rectangle, and I'm going to pick on the origin point because I want that centered right over the top of 0, 0, 0. That way I know that these little cutouts are right dead center of this pan. So now let's start slapping some dimensions to this. So I hit D for dimension, click on list parameters, and knockout width 1 is the one we want. Don't worry about it repositioning the rectangles. We'll locate those at a later time. Dimension again, we're going to go to list parameters, and this time we're going to go knockout length 1. This one we're going to go, oops. Oh, you know what happened is it automatically put a constraint that this rectangle is the same length as this one above it. So let's see if we can figure out where it's pulling it from. That's a good example right there. Sometimes these are a pain in the butt to try to figure out where it's coming from. Let's see if I can resize this. Nope. No. Okay, so it must be the bottom one. Oop, I just saw it. Okay, so by clicking on that point, which is a real pain in the butt, click on that point, it brings up all of the constraints that exist. You can see how up above, it'll turn this line red. When I highlight over the top of that constraint, I'm going to pick on it, left click, right click, and delete it. Now you see how it turned green again? Now we can resize this. That is such a pain that they do that all the time. So let's go back into list parameters and let's go knockout length 2. List parameters, let's go to knockout width 2. And then we're going to just grab on this line and we're going to move it up. Grab on this line and move it down. Make sure we don't get it anywhere close to anything else that it automatically constrains it. So let's do a dimension, D for dimension. Click on the top of the pan. Make sure you're not on the radius, but the top edge of the pan. Pull it off. We'll put 1 inch. Come down to the bottom edge of the pan, still in the dimension command. Pick on that horizontal line, pick on that horizontal line, and let's put 1. Now we've got our knockouts sketched out. Let's hit E for extrude. Pick on that, pick on that. Now that our extrude box open, we're going to say cut. We're going to go through all and say OK. Saying, hey, there's problems here. Okay, I'll edit it. I'll do F4 or function F4 for you, and you can see that it is trying to cut the air. We don't want it to cut the air, we want it to cut the pan. So I flipped that cut so that it's actually going into the pan, and now we have our cutouts. Next thing I'm going to do is I'm going to put some corner radiuses in here. So I came up into the sheet metal, corner round, pick on the corners. Apply. There we go. The only thing left is for us to put some holes in here. So I'm going to go ahead and select underneath the sheet metal again. Click on the hole. We want to make sure that the hole type is just a simple hole, not a clearance hole, not a thread hole, not a tapered threaded hole. And then also on the seat, we want to make sure that this little none is selected. We don't need a counter bore, countersink. We are going to go ahead and, since I've already done this once before, we are going to list parameters and we're going to do PEM nut hole diameter. And we are going to pick on the face that those belong in. I'm going to put 3 here. I'm going to put 3 here. And to orient these, I'm going to come over to the sketch. I'm going to do the front view. And before I select on the constraint, I'm going to do a crossing window, top left to bottom right, and I'm going to do vertical. And you see how they snap into place. I'm going to hit escape again, crossing window again, top left to bottom right, and there they are. Now they're vertically constrained, so I can move this one in. So let's go ahead and put a dimension. So D for dimension. Make sure you're picking on the outside of the pan to the center of the hole, 1 inch. Let's go ahead and put a dimension from the outside of the pan to the center of the hole, 1 inch. Outside of the pan, center of the hole, reference this. Since this one's going to be the same, I'm going to double click on this and reference this one. So everything is being driven off of this one dimension. So if I change this to 1.5 inches, you'll see that that changes, and so on and so forth. Now we could say, well, I don't want this to be 1.5 inches over. I want to leave this at 1 inch. I just take that reference off. But we do know that we want this hole spaced off of the edge of the pan, same as this one. So I'm going to hit D for dimension. Click on the outside of the pan, center of the hole, and reference that dimension. So you just click on top of the dimension and it'll reference it. Select OK. The next thing we want to do is do a horizontal constraint from hole to hole. So I'm going to come up to my constraints, click on the horizontal constraint, pick on that one, that one, that one, and the origin point, I want it in the center of the part. This one to this one, this one to this one. Now, As you can see, the crosshairs turned from that green, meaning that it was not constrained, to the black, and now it's fully constrained. I'm going to come back over to the properties here, click on hole, and say OK. Now we have our PEM holes. Perfect. Next thing I'm going to do is I'm going to go ahead and save this so that I can use it in, let's go flight. That's got to spin it up too. We are going to save it so that we can use it in the assembly. If you don't save it, it won't allow you to place the part inside of the assembly. More than likely, it just won't show up. I'm going to go training. Spelled it wrong. Let's spell it right. Nope. Double click on that, and we're going to go sheet metal pan. Next thing we need to do is go back over to Chrome, and we need to download this PEM nut. Make sure that it's on a 3D step file. Let's just make sure that they haven't started creating them for Inventor, and they have not. So I'm going to use a 3D step and save it. When you save it, make sure you know where you save it to. Come on. And let's track down your file. And let's go training. And I'm going to remove all this other garbage I don't need and just use the part number. If you left all of that in there, it's going to be in your part list as that full part number. So let's go back over to Inventor. Let's go File, Open. Track down your folder that you placed it in. And change this. This will be, you can see how there's no PEM nut there. I'm going to change this to a step file, and there it is. Double click on that part file, and it asks you, how do you want to convert it? 99% of the time, you can leave this as is. Some of the customers will send you over step files that just don't work. This is where you're going to come to fix that. That's for another date. We can go over those if you ever run into that. But for now, we're just going to go to OK. And we're going to change this to, let's just change it to steel. One thing you are going to have to do is give this a description. So let's go to File, Properties, Project. Change out the description to nut press in PEM quarter 20 steel. Okay, so if you look up here, we've got our McMaster-Carr part number, we've got our description. Go ahead and save that file, and then we're going to go File, New, and start an assembly. Hit P for place, or you can come up to the top left and place it. And again, we've got to go back through and find our training folder. We want to make sure that IPT is available because those are the two parts that we created. They're not assemblies, they're parts. You could just go ahead and go to the default of IPT IAM, so it gives you all of your files. But since we've only created part files, we're going to just click this, and you can see your parts there. We want to right click, place grounded at origin, hit escape, and we're going to go P for place again. And there is our PEM nut. Now we want that PEM nut facing the opposite direction. So I'm going to hit G, which is rotate. We're going to rotate the part. Why they use the shortcut key of G, I don't know, but that's what it is, and that's what it's been for a long time. So we're going to do a place constraint. Where that is right there, or you can see it also has the letter C in parentheses. So I always use the keyboard. So anytime that you hover over the top of these, it's going to give you the option. If it has it as a shortcut, it will give you, and of course, there we go. So P is in parentheses. That is your keyboard shortcut. N for create component for new. Okay, getting back to constraining that part, we're going to use an insert constraint. So far, as of today, we've only talked about the face mates. We're going to talk about an insert mate. This is one of the really nice features that, again, SolidWorks sadly does not have. So I'm going to use this insert. I want a 0 offset. I want to make sure that these little glasses are checked. What that means is it's going to give me a preview of the part being placed exactly where it's supposed to be. It's going to go ahead and move the part before I even say apply. Now I could deselect that, but I don't have any reason why I wouldn't want to see this part be moved over before I hit apply. So let's go in here and make sure that we're picking on that face right there, which is that shoulder. It's going to be pressed back into, and we place it. So now we want to hit apply because that's exactly where I want it to be. I'm going to come down, left click, do a Control C, or I can right click and say copy. You can see there's Control C, paste is Control V. So I've copied that. Now I want to go paste, paste, and I want to do C for constrain, come back over to insert, make sure that I'm picking the right surface, and pick on the back side of that, and there we go. Repeat the process. I don't need to hit C again because that window is still active. Hit apply. Now I don't have to close this to paste it. I'm just going to do Control V, Control V, Control V. But you see how our window disappears for the constraint. So now we have to hit C to do the constraint. Pick on that surface there. Pick on that surface there. And just repeat the process. And repeat the process again. Now there's tons of different shortcuts that you can do with this. We're showing you the very simplest way to get things assembled, a very standard way to do it, but we will cover all those other options at a later date. There's things called an iMate, that if you're going to be placing a ton of these, what you'll actually do is you'll open up the PEM nut and you'll actually create an iMate on that surface that we were just using. And what it does is it allows you to take those PEM nuts and just slide them over, and it'll automatically snap to that hole every time. It's super nice, super fast, and it's unfortunately one of those things that SolidWorks doesn't have again. So we've got our part. It's looking great. One of the things, let's go ahead and save this to weldment. Yeah, weldment pan. And there's my dogs. Let's go to File, New, and let's start up your drawing. So I'm going to right click, go to the base view, and let's make sure that that is the face that we're looking at. Sometimes you'll have the back of the pan for some dumb reason, but that is correct. That is what we want. I'm going to place a few views and select OK. What I do like to do is I'll use fractional scaling. Why it had 0.16, it's just basing it off of the size of the sheet and what it thinks would be the optimum scale. I'm sorry, I'm getting ahead of myself. So I just turned off the label for the isometric. I never have it on there. If you're not smart enough to know that that's an isometric, you shouldn't be doing any of this stuff. Anyway, so we've got our other views. I'm going to double click on this front view, take off the one, double click on the top view, call that a top, double click on the side view, and I'm going to go side. And those are our four views that we typically use. One thing I do like to do is I like to render this image but leave these other images so that they're just regular old 2D drawings. Makes it easy for when you're applying dimensions. The other thing I also don't like seeing a lot of times is I will not have the hidden lines in there. It just makes it confusing. For this purpose, it's a very simple drawing. We're going to go ahead and leave the hidden lines on here. Next thing I want to do is I want to place my parts list. One of the reasons why I want to place the parts list is so that I know that my dimensions won't be overlapping them. I can set my dimensions first time without having to move them over and over and over again. Okay, so we've got our drawing, we've got our parts list. First thing I noticed, description, it's missing. So let's right click on the sheet metal pan, which is the part number, and go to open. This is where I was talking about you want to get rid of the length and width inside of here. Reason being is when you go to the flat pattern, it uses, for some reason, a different set of parameters that will not allow you to create a new length and a new width. And we want to export, say done. I'm going to sketch on this face here. It says, hey, you can't change any of these dimensions because it's driven from the folded view. I'm going to hit D for dimension, go to the overall length, accept that, go to the overall width, accept that, come back into my parameters. Now there's two different ways that we could do this. I didn't have to create these user parameters. I could have just renamed these two, and in fact that's typically what I do, so I'm going to go ahead and just delete that. Okay, so I always use the length as being the longest dimension, and I'm going to use this width, the shorter of the two for the width. Make sure that the export parameter is selected, say done, finish the 2D sketch. Let's go back to our formed view, save it, perfect. Let's go back to our drawing and look at our length, and the width has been updated, but our description still has not been updated because I forgot. Let's go back and open that up. Let's go into the iProperties, go to project. We're going to hit equals. We're going to go equals sheet, comma, sheet metal rule, comma, material, spell it right, appearance, close it, Rev. Let's take a look at it, make sure that it's right. Oh my gosh, what did I do wrong? Ha! I did something wrong. Glitch. Evidently I didn't do anything wrong. Anyway, so we've got a sheet, 14 gauge, galvanized, steel, mild, semi-polished. Again, let's just go and select this. Go to hit G for galvanized, change that. We're good here. Let's go back into the iProperties, go to project, and now we're looking good. 14 gauge, galvanized, steel mild, galvanized. A little bit redundant, don't care. More information as long as it's correct is better. Now we are set. I'm not going to cover the dimensions for now because, or dimensioning out the sheet, because this one has gone on long enough and I am needing to cook dinner. So hopefully this explains a little bit about how to get you started on sheet metal. We'll get into much more detail later on as we get along. Okay, we'll talk to you later.